Good morning. This is pre-algebra for Tuesday, April the 7th. Today we're going to talk about multiplication of scientific notation. Doesn't that sound super impressive and super smart? Well, don't tell anybody because it's super easy, okay? All right, here's what we're going to do. We have a simple multiplication problem. We have 4 times 10 to the 5th power times 2 times 10 to the negative 2nd power. It's a couple steps. First step, multiply the first term in your problem. In other words, 4 times 2. 4 times 2 gives us 8. So we're going to write our 8 down. Now we know that this is in powers of 10, so we're going to write times 10. Now we have to decide what the power is. Simply add your exponents. Positive 5 plus a negative 2 is a positive 3. So our answer is 8 times 10 to the 3rd power. Look at the next one. 3 times 10 to the 8th times 3 times 10 to the 3rd. Again, multiply the first two numbers. 3 times 3 is 9. We're going to stay with our times 10. Now add your exponents. 8 plus 3. Since both of them are positive, our answer is 9 times 10 to the 11th power. Look at the next one. 4 times 10 to the 6th, negative 6, times 2 times 10 to the 4th. Let's multiply our first two numbers. So 4 times 2 is 8. Keep the fact that it's going to be the power of 10. Add your exponents. Negative 6 plus positive 4 is a negative 2. So our answer is 8 times 10 to the negative 2nd power. Look in your math book for me at page 225. Page 225. We're going to look at the practice section together. Look at letter A. It says 4 times 10 to the negative 4th power times 2 times 10 to the positive 14th power. What would your answer be? Multiply your first two numbers. Times 10. Now add the exponents. Okay, your answer should have been 8 times 10 to the 10th power. Look at letter B, go across. It says 3 times 10 to the 6th power times 3 times 10 to the negative 2nd. Okay, multiply your first numbers times 10. Now put down your power. Your answer should have been 9 times 10 to the 4th power. Try letter C. If you have 2 times 10 to the 10th power plus 2 times 10 to the 3rd power, what would your answer be? Multiply the first two. 2 times 2 is 4. And times 10 to the 13th power. Look at number D. 2 times 10 to the 5th power, it's a negative 5th power, times 3 times 10 to the negative 8th power. That gives us, multiply our first two numbers and get 6 times 10. Add your exponents to get the power of negative 13. Let's look at problem set 80. It says Ingrid used 2 eggs to make 153 cookies. How many eggs would she need to make 1,071 cookies? Now I'm going to suggest to you, because this is going to make your homework easier, if you will write these down, do these with me. Okay, that's the point of this, okay? So first, what's her ratio? How many eggs to how many cookies? It is 2 eggs to 153 cookies, okay? 2 eggs to 153 cookies. Now, how many cookies did she want to make? She wants to make 1,071 cookies. So we're going to take this ratio and we're going to multiply it by the number of cookies that she wants to make. So 1,071 cookies. Okay, so what are we going to do? Well, we're going to get rid of the label cookies first because it cancels out. Okay, Then I'm going to say, can I cancel anything? I can't. I can divide 153 into 1,071 7 times. So I'm going to mark this out and put 7. Mark this out and put 1. Now all I need to do is multiply. 2 times 7 equals 14. And 1 times nothing equals 1. So we have 14. What's my label? My label is eggs. She needs 14 eggs to make 1,071 cookies. She also needs a very big oven or lots and lots of time. All right, look at number 2. The ratio of noisy ones to quiet ones. Let's say that these are 7th graders, okay? These are children, or teenagers, sorry. Okay, the ratio of noisy teenagers to quiet teenagers, okay, is 13 to 5. Okay, so there are 13 noisy teenagers to 5 quiet teenagers. That pretty much describes our class, all right? Now it says, what if, oh my goodness, could you imagine? You had 3,900 noisy junior hires, okay? How many junior hires would you have in all? Remember, 13 represents noisy, and so does the 3,900. 5 represents the quiet. I'm looking to find out how many quiet ones I would have. So I'm going to put an X because I don't know. Now I'm going to say 13 times X is 13X. And then I'm going to say 5 times 3,900 is 19,500. Okay, all I said was 5 times 0 is 0. 5 times 0 is 0. 5 times 9 is 45. Put our 5 down and carry the 4. 5 times 3 was 15 plus the 4, and I got 19. So I have 13x equals 19,500. What do I do? When I have an equation, I have 2 things I must remember. Number 1, do the opposite of what the equation says. And number 2, whatever you do on the left, you must do on the right. This says to multiply, so I'm going to divide. Since I'm dividing on the left, I must divide by the same number on the right. This cancels, leaving x. How many times will 13 go into 19,500? Well, 13 goes into 19 one time, okay? Then we have, with a 6 left over, 13 goes into 65 5 times. 13 goes into 0, 0, and into 0, 0. Our answer is x equals 1,500. So if you had 3,900 noisy 7th graders, you would have 1,500 quiet 7th graders. Not sure there's that many quiet 7th graders, but we'll go with it. Let's look at number 3. It says, Twain, this is referring to Mark Twain, the American author. Mark Twain traveled the first 200 miles to Calvaris in 4 hours. Then, in the mountains, he slowed to half that speed. If the total trip was 300 miles, how many hours did it take Twain to complete his trip? If you've never read the story of Mark Twain about the celebrated jumping frog of Calvaris County, it is a very hilarious story about some boys who get a frog, and back in the mountains, they would have these frog jumping contests, and the boys would catch frogs, and they would get these frogs, and they would see who could jump, which frog would jump the furthest, or which one would jump the fastest a certain amount of length. And it was a big deal. Why? Well, these were poor children that didn't have any toys, they didn't have much money, they didn't have any money, and so they found ways to have competitions and to occupy themselves. Well, this is a story that Mark Twain wrote about a frog at a county fair and all the mischief that is led there too. So it's a celebrated jumping frog of Calvaris County. Now, let's look at this. Mark Twain, by the way, he wrote some other good books. He wrote Huckleberry Finn. He wrote Tom Sawyer. Those are a couple of other books that he has written. Mark Twain traveled the first 200 miles in 4 hours. So we know how fast he's going, okay? He's going in 4 hours, he's traveling 200 miles. Okay? We know that. But what we need to know is what's his new speed? Because the story problem told us that when he got to the mountains, he slowed his speed to half. Okay? So what we're going to do is we're going to multiply this by 1/2 because he did half the miles in that. Okay? So when we work this out, we know that this is going to be, excuse me, we're going to work this out and we're going to say that he's going to travel 100 miles at this speed. Okay? How do I know that? How do I know that he's going to travel 100 miles? Well, because it told us that the whole trip was 300 miles and that he had already traveled 200, so he only has 100 miles left. That is where we got the 100 miles, okay? So, first of all, what can I cancel? Well, I can cancel out my miles and my miles, okay? Then I say, well, what's 200 times 1/2? That equals 100. So if this equals 100 and that's 100, I can cancel this out and write 1. Mark this out and write 1, okay? So let's look at it again. We took the ratio of 4 hours of 200 miles, but it told us he cut his speed in half. That's where this came from. So we have 4 hours in half of these miles, okay? We had 100 miles left to travel because we knew the whole trip was 300 miles. We've already traveled 200. We have 100 left. We're able to cross out our labels of miles. Then we cross out 100 because 200 times 1/2 is also 100. So now we have 4 times 1. It is 4 hours. So he traveled the second part of that trip, the last 100 miles, in 4 hours. But that's not our question. Our question was, look at number 3. How many hours did it take Twain to complete his trip? Well, he did the first 200 miles in 4 hours. He did the last 100 miles also in 4 hours. So the whole trip, your final answer is 8 hours. Make sure you don't put 4 hours. It's 8 hours. How long was the whole trip? Look at number 4. We're going to talk about spelunkers. Spelunkers are people that explore caves. I would not be a great spelunker. I enjoy going into caves, but I want to know that they're safe. I don't want to go in there and find a bunch of bats or a cliff or fall off of something. My husband hates caves. He hates them. Doesn't like tight, dark places. He would not be a good spelunker, okay? The word spelunker simply means a cave explorer, okay? Number 4, when the spelunkers entered the cave, 4/5 of them got excited. How many of you would get excited about going into a dark, unexplored cave? All right? If there were 1,650 spelunkers in all, how many were excited? Well, first, we have to remember there were 4/5 were excited, okay? If that's true, guys, how many were not excited? Well, 5/5 or 1, the whole group, we would say 5/5 minus 4/5, that means that 1/5 were not. They were not excited, okay? They were not happy about this trip, all right? Now the question is, how many were not excited? Well, now I can solve my problem by using my pattern. I know that I take, what's my fraction pattern? My fraction pattern is the fraction times the of equals the is. Okay, so what's your fraction? We're looking at the ones that were not excited. Okay, so we're going to say 1/5 times the of is the part we do not, no, we do know. I'm sorry. It's 1,650 spelunkers, okay? So if there were 1,650 spelunkers in all, how many of them are not excited? I'm simply going to multiply this. I'm going to divide this by 5. 5 goes into 16. 3 times with 1 left over. 5 goes into 15, 3 times with a 0. Now I'm going to multiply. So how many of our cave spelunkers were not excited about this journey? 330 of them. Let's look at number 5 very quickly. I want to do this quickly because our video doesn't like it when I make these very long. All right? Let's look at our statement. The statement is x is greater than or equal to. It can be both of these. -2. How do we graph it? Well, we're going to make our number line. Do this real quickly. And then we're going to say, first, it says it's greater than or equal to. Since it says equal to, what are we going to do to the dot? We're going to color it in. Okay, so go to the -2, color in the dot. Now do what? X is greater than. Well, which side is greater than -2? It goes this direction. Okay, look at your next one. It says X is less than 3. Okay, so this time when I make my number line, make it real quickly here. It's less than 3. So I'm going to find the 3. It's right here. Because it's only less than, I'm going to circle. I fill it in if it says equal to. I leave it open if there's no equal mark, okay? And it says that X is less than 3. So which side of 3 is less? We're going to go to the left, okay? I hope this has been a help to you today. I want to get some more problems done with you, but I have to shut off for now. So what I want you to do is I'm going to have a certain number of these that are on your homework today. Please remember, if you complete the homework, and I leave it on so you can see it, if you complete the homework and you get above a 70, you can go back and correct them, guys. There's no reason not to get a 70 or higher. If you get above a 70% of them correct, you get 100 for that grade. The quiz, let me remind you, you may not use your calculators on your quizzes. You need to be able to do them without a calculator, okay? All right, I miss you. Have a great day.